Consider the function in the graph to the right. The function is increasing on the intervals, decreasing on which intervals, and the domain is what? All right, so to determine increasing and decreasing, generally what we first observe is if we are looking at the graph going from left to right. That's really important because otherwise you're reading the opposite direction. So we're looking for values of the graph that are going up in value. So that means it's increasing. So we're increasing up to this particular point, but it's no longer increasing there. And then we are decreasing for a little while between those points. So starting here, but not including, but then going to here and not including. And then we turn and we're start to increase again. Now, it's tempting to say that we stop here, but unless it's indicated with a closed circle or an open circle, you just want to assume that it continues on in the same fashion. It's just not a lot of technology draws these arrows, so that's fine. But you just assume that they're there. So what this means is, since we've identified where it's increasing or decreasing, how do we go about answering that properly? So the way we answer that properly is we answer based off of the x-axis for that particular range. So the x-axis interval for this range, let's see, we'll put this in as a reference at 2. And all these points exist. So all these points here, up to where this arrow is, and it gets a little short there, but the arrow isn't indicating that it's going to infinity in that direction. So we're increasing on the interval from negative infinity all the way to 2. And then again, here's this point for starting reference. All of these green values are part of the x interval where we are increasing. And then we have this arrow telling us it goes off to infinity. So then we also have a set from 7 to infinity. Now it's tempting to say it stops at 10, but again, that arrow indicates it goes to infinity. The decreasing intervals are all the values within the range where the y values are going down in value. So the x intervals are starting here at 2 and ending here at 7. And all of these points in between have y values that are decreasing in value. So that set is from 2 to 7. The domain of the function and the range of the function, we can find those if you think about all of the x values that have an associated y value. Right, so all the x values that have an associated y value would basically be the sets where we're either increasing, decreasing, or constant, which would be all of the values, including these points here. So the domain is all the values from negative infinity to positive infinity, and then the range is similar. It's all of the y values that have an associated x value, which is all real numbers. Another way you can think of domain and range is if you considered smashing the graph up against the x and y axes. Then the resulting smashed graph up against the x-axis would be the domain, and the resulting smashed graph up against the y-axis would be the range. Let me show you how that would look. So here's a similar graph, and if we imagined it being smashed up against the x-axis, the resulting set of x values would be the domain. Now, of course, don't forget the arrows that should be here, but the technology isn't drawing them, indicating that the domain would be all the values from negative infinity to positive infinity. Likewise, if we smashed everything up against the y-axis instead, then we end up with, again, the set from negative infinity to positive infinity, which is the range of the function.